Bismillahirrahmanirrahim. Today I would like to share the knowledge about the parameters for primer pair design. This one is the important for the researchers who are working and who are performing the PCR technique. The number one is the Amplicon length. The Amplicon length is dictated by the experimental goals, and for qPCR the target length is closer to the 100 base pair, and for standard PCR it is near to the 500 base pair. So this is that if you know about position of the emitter to the template, the product is calculated as the product length is equal to the position of the antisense primers minus position of sense primers plus 1. This one is then how can you calculate the product length, and below is that the sketch of diagram that the Amplicon coverage, that forward primer, reverse primer. So this one is the Amplicon. So this is the partial coverage and the full coverage. You can see that what is the difference between these two figures. Next is product position, and this one is the primer can be located 5 end and the 3 end or anywhere within the specified length. Generally the sequence close to that the 3 end is known with greater confidence and hence frequently. Here you can see in this that the image, you can see that these are the product size, that 357 base pair. So different DNA has the different product, and you can observe in this diagram. So next one is the Tm of the product. The melting temperature is the temperature at which 1/2 of the DNA duplex will dissociate and become single stranded. The stability of the primer template DNA duplex can be measured by temperature. So next one is that you can see in this diagram that this is the Tm of that melting temperature in this diagram, and next is the optimum annealing temperature, that how can you calculate. The formula of the Rayleigh is the most respected. Our product use this formula to calculate it, and thousands of our customers have reported good results using it for the annealing step of the PCR cycle. It usually results in product yield with minimum false product production. The TA optimum is equal to 0.3 multiply Tm of the primer plus 0.7 multiply that the Tm of the product minus 14.9, and about these terms, that Tm of the primer is that the melting temperature of the less stable primer template pair. Tm of the product is melting temperature of the PCR product. So you can see that the primer pair Tm mismatch calculation. The two primer of a primer pair should have closely matched melting temperatures for maximizing the PCR product yields. The difference of their 5 degrees centigrade or more can lead to amplification. The primer designing the software, these are very important. A number of the primer design tools are available that can assist in PCR primer design for new and experienced users alike. These tools may reduce the cost time involved in experimentation by lowering the chances of the failed experimentation. Next is that the primer premier that follows all the guidelines specified for the PCR primer design. The primer premier that can be used to design the primer for single template alignment, generate primer design, restriction enzymes analysis, and contage the analysis and design of the sequencing primers. The guidelines for qPCR design vary shortly. The software such as the allele beacon designer can design primers and oligonucleotide probes for complex detection assays such as multiplex cross-species primer design and species-specific primer design, and the primer design reduce the cost of the experimentation. PrimerPlex is also a software that can design the primer for multiplex PCR and the multiplex SNP genotype assays. Now this one is the references. You can see here all the detail about this primer designing, and this one is the short and brief video. If you have any query or any question, you can put at my YouTube channel. I will give the answer and as soon as possible. Thank you so much for listening to this short video.